So what is lockout tagout? A lot of people wonder, why can't you just use a lock? Why can't you just use a tag? Why couldn't you? Why couldn't you just use a lock on something? We've got locks right here. Why couldn't we just put one of these on a source to prevent it from being re-energized while we're working on it?
Because it could be cut off.
It could be cut off, so could ones with tags. But what doesn't this tell somebody else who's in the area?
Who's working on it?
Who's working on it, that it's actually locked out, that this lock represents somebody's life on the line. All this shows them as a barrier. And you're right, it's much more likely to be cut off if they don't see somebody's life on the line and associate that with that lock. So that's why locks and tags work together, and they are important. So the lockout's the placement of a lock on energy disconnect to physically prevent them, and tags to place an information tag on the energy disconnect. Together, lockout tagout communicates to people in the area or working on the machine that you've locked it out, you have control of the energy, and your life is on the line, not to remove that. So why you need lockout tagout? For one, OSHA requires it. That shouldn't be your driving force, but if it is, year after year, 1910.147 is consistently one of the most cited violations, costing companies millions of dollars. Last year was 3.6 million, and it's going up this year. Just recently, there was a company cited nearly $2 million for one incident of lockout tagout violation when there was a death in the facility. And that was just a violation from OSHA. Anybody know what company that was? It's in Google search, so it's public knowledge. It was Cintas. It was the historically largest company or largest fine ever issued to a service company. $2 million. It was somebody caught in a dryer. I don't know if you ever heard of that one. It's a horrible story. We'll get into that if we have time. So really importantly, when you're starting, you need to know which equipment need procedures. And this is where we went up to your facility up at, what's that facility called?
It's sand separation and the water plant, relay.
Where they're dredging out the, what river?
Fox River.
Fox River, sorry. And taking all the contaminants out of the soil and water and pushing it back clean. They have a couple hundred pieces of equipment on site there, and the first step before we started there was evaluate what equipment needs procedures. That's not an easy task because you have to run it through 8 criteria, and we'll go over what those are. So what 3 major components are required for a complete lockout tagout program? I kind of mentioned them, but I was scattered when I mentioned them. We know one, so we just talked about it. Procedures.
Training.
Yep.
Hardware.
Your hardware is going to fall under your procedures. Yeah. So your procedures and training, and one more component OSHA requires. Evaluation and auditing your program, making sure you keep it up to speed. Like I said, it's not something you just put on a shelf and you're done with. And there's actually an additional component, and I've been talking to OSHA about actually having that put in the regulation because so many people fail to do it. Corporate policy. You have to show how the procedures work with the devices, that work with the auditing, and who's responsible, and how do you correct deviations. So your corporate policy is really a 4th component on there. Not in the minimum requirements, but it's really needed for a successful program. So training and audits, procedures and policy. So there's really 4 components there. First, the training and auditing. Training must be provided to every authorized employee who will be applying locks to the isolation point. So we kind of answered what an authorized employee is. Quite simply, it's anybody using the locks. Everybody else is going to be affected employees. People who are in the area, they need to be trained to know what that means when there's a lock and tag on there. Generally know what the lockout procedures look like, not to use them. And then the authorized employees need to be trained further, like today, how to use them, what the intent of the regulation is, and so forth. Training must be given to employees before a lockout's ever administered, at least annually thereafter. So we say at least annually thereafter because it simplifies it. There's probably 3 or 4 criteria necessary for retraining to occur. It's when there's change in equipment, change in job assignment, or new lockout procedures are introduced. These things are happening all the time. So it would drive you nuts to try to regulate and keep track of when you have to actually retrain each person individually. It's easiest, in our opinions, it's easiest to just give training annually as a refresher to make sure everybody's on the same page annually and do your auditing at the same time. The audits are to include an annual inspection of the procedures, every procedure, not just one or two, and at least a sampling of the process, so you'd asked about that, utilized by the authorized employees. So you don't have to do every process, every employee. You group the employees together, pick one that represents each group, and then pick a different person out of that group every year, and then audit different machines every year. So we recommend the process to be inspected monthly or quarterly so that you're going out there to make sure they're complying with the program, and procedures annually. If deficiencies are identified, they should be clearly documented and corrected immediately, not waiting for an annual audit to catch it. The second component, procedures. Procedures should be created for all equipment with 2 or more energy sources, and that's just one of the 8 criteria. We'll go into that. But knowing this one criteria, if a piece of equipment is a cord and plug style like a drill, is a machine-specific lockout tagout procedure required? Kind of a trick question, right? Depends on a lot of other information. What would your gut instinct be, though? If it's a drill press or a drill, okay, we'll assume it's a drill press then. And then does it need a procedure?
Yes.
And why would it need a procedure, even if it's just cord and plug?
So some idiots can go plug it in.
On all the plugging and the spinning of the
Right.
spinning.
Kinetic energy and electric energy. It's not just lockable energy sources. It's anything there's like that exhaust fan we looked at. Kinetic energy and electric energy, there's 2 sources. So then the second question, does it still need to be locked out if you're servicing it? We know if it's a drill press, we know it needs a procedure now, but do you still have to lock it out every time you service it? Well, yes, it's best to be on the safe side and assume yes, but actually you don't. And the regulation will even tell you that. You don't have to lock it out every time, which kind of makes sense, right? If you're keeping the intent of the regulation, which is preventing unexpected re-energization of the equipment, I'll say that again. The intent is to prevent unexpected re-energization of the equipment, to prevent harm to you primarily. Then if you can unplug that drill and keep that plug right in front of you at all times, you've met the intent, right? There's nobody that can plug that drill in and get it going without you being in the way, essentially. So you've met the intent with that, but as soon as you leave, you're like, oh, I forgot the belts. I'm going to leave this plug right here and I'll be right back. Now you've lost exclusive control of that. Now you have to lock it out if you're leaving. So when we train, we don't go into that gray area too much because we like to just define it for them and say, you need to lock it out for these pieces of equipment when you do this service, and you can safely avoid lockouts for these services, rather than leaving it up to the authorized employees to kind of decide each time. Does that make sense? As long as you can meet the intent, you don't have to lock it out. But that's only with one energy source when it's already, you can't do that with 2 lockable energy sources. So the corporate policy was the third component I mentioned. Must specifically detail the means of enforcement, describe protocol to correct deviations, and it should have a decision flow chart so that you know what's the logic used when you're creating new procedures and when create new procedures. So overall, a good corporate policy should act as a guide for the employees to follow that the company approves. It prevents misunderstanding and miscommunication between the management and employees. If anybody's ever going to get penalized for something, they at least need to know up front what the rules are. That's what a corporate policy is for. I had mentioned the 8 criteria. They luckily aren't as complicated as they look. They're very redundant, so there's really only about 4 different ideas there. The first one, have no potential for stored or residual energy. If something has a capacitor in it, kinetic energy, potential energy, then it has a potential for stored energy, right? And it's also going to have power outside of that. Have one energy disconnect which can be easily isolated. And we highlighted the word easily, we made it boldface, because if it has one energy disconnect but it's not easily isolated, and by easily I mean pretty obvious when you're standing there. The OSHA doesn't give a limit like 13 feet away or marked red or a big box, not a little box. They just say easily isolated. Then you have to create a procedure for it because there's confusion. Somebody may say, I think it's that breaker, and there's 4 unmarked breakers there, and they trip one and they start working on it and they get electrocuted. So that's why it has to be easily isolated. Number 3, be completely isolated and deactivated by that one disconnect. Number 4, be able to be locked out during service or maintenance, so you're not working on something that supplies fresh air to a room or something like that.